So I was asked to talk a little bit about how I see the future and the skills that might be important for the future. So it will be slightly different from the other talks, but I will start by talking about very briefly about my own background, and then about Boliden as a company, and Boliden Exploration, which is the unit that I belong to and that this talk sort of also covers. What types of roles there are in there and for geoscientists very briefly. And then I will go into the research and development, which is my own area in the company at the moment. And then hopefully end up on some ideas for what might be important for the future as well. And then at the end, I'll throw in a slide with some student opportunities as well. So Tobias Hermansson is my name. And I am currently manager for the expert group Exploration, which is the research and development department in Boliden Exploration. I started out in Lund doing a master's thesis on structural geology in the Kaledonides in 2001. And then I did my PhD as well in Lund. There I studied the tectonic evolution of the western part of the Svekofenian orogeny in central Sweden. And I did that job as part of the site investigation at Forsmark for the nuclear waste management company. After finishing the PhD, I went on to Boliden and I worked as a specialist in structural geology and 3D modeling as well. So I worked quite a lot with developing or trying to find new ways for the company to integrate data in 3D and these kind of things. So I've just thrown in a couple of pictures of stuff that I've done during my years here as a sample. And then in 2018, I got the opportunity to actually build this little research development department from scratch. So I started out and have hired a few people, and we're now working, still looking for people. I'm hiring at the moment, actually. So a little bit about Boliden as a company. So as you know, Boliden is a metals company, and it's has the whole value chain from exploration, where I work, through mining and concentrating and to smelting and finished metal. And we also do recycling, actually, of e-scrap and things like that. So it's quite exciting company to work for, since we have the whole value chain, basically, and lots of expertise in all of these areas. We have 5 mining units, which are the ones that you can see in dark blue here. In Finland, Sweden, and on Ireland. 5 smelters as well in Finland, Sweden, and 1 in Norway. We're roughly 6,000 employees in the company in total, and we're approaching 100 years now, so it's an old company. And we work basically mostly in base metals, but we also do some precious metals as byproducts. So that's about the company. And then if we go into the exploration organization, it is organized like this. You can see in the background on the map that the blue dots there is where we have offices with geoscientists working. So 6 offices in 3 different countries, and we're about 130 employees at the moment. Right now, we're 16 nationalities. We've been more, actually. This is a very international group. It's exciting to work in it for that reason as well. People from all over the world. And as you can see on the organizational chart here, we have the exploration director, and under him we have 6 departments, in all of which there are geoscientists. So we could maybe start with field exploration, because that's where it starts, where we try to figure out where a new mining area is. That is then goes into near mine exploration, which takes over projects from field exploration and start drilling them to understand more exactly how much there is in there. They will eventually hand over to ore reserves and project evaluation, who calculate the resource that then can be handed over to the mines. But then we have support functions as well, exploration geophysics, for example. In Boliden, we also develop our own EM, electromagnetic systems. So we have a lab as well under this department. Geodata deals with our databases and maps and tenements and things like this. And then we have the little research and development group that I'm heading. So that's a flavor for you to see that there are loads of places in this organization where there is space for geologists. And apart from this, of course, we also have geologists at the mines in production. Those are not organized under exploration, but under the mining units. And then we also have a few geoscientists working in the sustainability and environmental departments. So there are loads of opportunities in this company. And I would say that if you want to use your whole toolkit as a geoscientist, then mineral exploration might actually be the job for you, because we actually try to understand the geology properly in the areas we're working. Of course, our job is to try to find metals in the ground in amounts that are economic to mine. And to do that, we really need to understand the ore forming processes. We need to understand the vectors towards ore so that we can zoom in on where the good stuff is. And we need to understand what has happened geologically since the ore formed as well. And all of this knowledge we then combine to try to select the best areas to explore. When we found that area, we start collecting even more information and home in on targets, and eventually, hopefully, we find something. And just to show, this is not an exhaustive list in any way, but some of the disciplines that are involved, or the knowledge base that's involved in this work, includes geophysics, petrophysics, geochemistry, quaternary geology, mineralogy, petrology, volcanology, sedimentology, structural geology. We look at tectonics on large scales as well. And then, of course, we need to make maps and 3D models, so GIS and various 3D modeling softwares as well. So we do geophysical surveys, both magnetic surveys and gravity surveys, and then we have several different EM systems we're looking at. We do bedrock mapping out in the field, and then a lot of diamond drilling, because obviously there is not outcrops everywhere, but also to get at the good stuff at depth, we need to drill. Geochemistry is done both on soil and on drill core and on hand samples from outcrops. So all of this information actually we use to try to understand where we are and where we want to go. And it all starts with research, but then as we collect this information, of course, we update the models and update our understanding as we go. So hopefully we improve with time. If we look a little bit at my group and the research challenges looking for the future, our main challenges relates to the fact that we need to find or make discoveries at increasing depths. A lot of the stuff at the surface has been found, so we need to become better at finding things at 500 meters and below that. And we want to do this with minimal environmental impact and maintain social license to operate, meaning that the society around accepts us and wants us there, right? And there are a lot of challenges in there and a lot we can do. So one of the things we're doing is collecting new types of data that we didn't have before, and this can hopefully unlock new search spaces for us, maybe in the same areas we are already. We also look at old data, but with maybe new processing technology or new ways of modeling, and sometimes can tease out more information from that legacy data. We're trying to improve our understanding and application of mineral systems approach in both 3D and 4D, and this is basically geology, understanding the overall system where the ore forms. And then, of course, the more data we collect, we need to do something with all of this data. It's very easy to collect a lot of data and then no information comes out of it because it's just overwhelming. So all of the new data needs to be analyzed and processed and treated in a way that it actually produces something that's useful and not just data collection. So all of this is really about de-risking the exploration process. What we do the most in exploration is fail, and we want to try to fail fast and spending as little money as possible doing that, so we can go on to the next thing. So that's a little bit about the background there. And if we look at the research and development, how we've organized that work, we have development. By development, I mean things we're doing in-house, improving data quality and working on workflows and training personnel and this kind of stuff. But the research itself is now organized in 3 different programs. So 1 data acquisition, 1 modeling and visualization, and 1 mineral systems knowledge, which is then the geological part. And I thought at the moment I think we have 13 projects going on with various research partners, universities. It's in EU projects, and we got projects with partners in Australia and Canada. Roughly 13 projects at the moment. And since I started this little group, we've actually been dealing with in total 27 projects. So we're doing quite a lot on the research side. Small projects and big projects. So just to give you a flavor, I will just give you 1 example or 2 from each of these programs. So the first one is actually a PhD project on our Nautanen deposit in Norrbotten. And here we have an in-house PhD student who worked for us before and is now doing his PhD on the job. And he's working on the characteristics of the Nautanen deposit and how it's related to porphyry and iron oxide apatite mineralization. And the end goal, of course, is to figure out how we find the next deposit. If we look a little bit on the modeling and visualization side, I mentioned 3D modeling before. This is something I've been involved in myself, common earth modeling and integrated interpretation, in which basically we're integrating all the different types of data we have in 3D, but we don't just stick it there together. We actually let each data type influence the model so that the end result is a model that honors all the different data types. So this is an iterative process going back and forth in the modeling. And the end result gives also a sort of a raster model in which each of the cells has a value for the different data types we have. So we can start querying this in various ways, and we can do quantitative mineral potential mapping and things like this in 3D with varying results, of course. It's all about how good the data is. So that's a bit of modeling. If we look at visualization, we're looking at the moment at how we can use virtual reality for mapping in the mines. So what you're looking at right now is a software that has been, or it's under development. It's beta stage at the moment, but it's been developed in an EU EIT raw materials project called Farmin. And Terranigma, as you see the logo at the bottom there, is a startup company who develops this, and Boliden and my group has been deeply involved in helping them work on this software. And this software is not just visualizing 3D models in virtual reality. It's actually a collaboration platform so that you can use almost any hardware and we can be in the same virtual space at the same time. So at the end of the day, we're hoping that we will be able to scan or use photogrammetry in the mines so that geologists can stand up in the office in virtual reality and do the mapping and don't have to travel and also stay out of the risky zones in terms of safety. It also unlocks the possibility for having support from an expert that maybe sits in Finland and not where I am or something like that, to work on 3D data in real time. In the background here also, I think you saw a glimpse of a 3D model. There's a 3D modeling engine called GenPy here in the background as well. And the idea is that in the future, you will be able to actually do real-time modeling as well in the virtual space. So that's quite exciting. And then on the data acquisition part of the research, we are at the moment running a quite big program that we call the Future Logging Assistant. And what we do here is combining geology with artificial intelligence and machine learning. So we're collecting, and have been doing so during a couple of years now, collecting continuous data sets of a new type that we haven't used before. We're scanning drill core. You can see up here, for example, is the Ore Explorer's core scanner, which is doing actual tomography of the core as well as XRF geochemistry. We have mineralized scanner that is an XRF scanner as well, scans straight in the core box. And then we built our own little photo booth to take UV photos of drill core as well. And we will continue working this year with hyperspectral data. So on the development side here from Boliden, my team is actually collecting this type of data, and we're looking at how we can use it as it is right now. But at the same time, we're moving those data sets over to our two researchers. So we have we're fully funding 2 PhD students at Luleå University of Technology at the moment. And here we have Philip, who is a geologist, and we got Christian, who is a data scientist. I will come back to this in a moment, but I think this is key for the future. We're not trying to do everything ourselves. We need to create strong teams. So just to give you a flavor for what the questions in this Future Logging Assistant program, what questions we're trying to answer. I'm not going to go through all of these, but I highlighted a few. So how can we make core logging or the data collection part more efficient? This is not about making the geologist go away. It's about helping the geologist with the tedious work. How can we best amplify the knowledge extracted from each drill core by adding new data with the scanning technologies and integrating existing data using AI and machine learning? How do we promote high consistency between different logging geologists with different experience and skill? This is actually a quite big problem when you're doing 3D modeling and you're using legacy data from 30 different geologists. It's kind of hard sometimes to know which units to match up. So this is something where we hope this can help a lot. And also on our side, and not so much on the research side, we need to understand how we can collect data sets that are suitable for AI and machine learning. And will that change the way we work here? And then one interesting question is how and if we can teach the tool somehow to learn to make decisions from context, because that's what we're doing as geologists, and I will come back to that in a moment as well. And then just another question at the bottom here, which maybe is not that obvious, but how do we know if we're successful in this project? How do we measure that? It's not that easy. So those are some of the questions we're dealing with here. So moving on, what skills will be important in the future? Well, to start with, geology is complicated, very complicated, and we should be kind of proud about of what we're doing when we're working. That's something we're realizing now that we're working with the machine learning as well. It's more complicated than many data scientists seem to understand anyway. We've scared a few on showing them what we're doing and trying to make them understand. So the understanding of what we're looking at when we're mapping or logging, that doesn't only come from the integration of data and information that you collect from the sample you have in front of you. You actually make decisions based on other things, based on things you've seen in the area locally that can inform you, and you've seen a contact between two different rock units somewhere might make you decide that what you're looking at right now is rock type 1 and not B. You also have the context of what you know from before you've seen from similar systems. And this is really fundamental to be able to interpret geology correctly. When we feed the information into the computer for AI and machine learning, it will see what it has in front of you. It's the data right there. So how do we get this context to come in there? And this is an obvious thing that it's not going to be easy, and the human certainly has a place in this. So you don't have to be worried that the geologists will go away. You are super important. And that's my point here. Do not underestimate the importance of properly understanding the geological data. Geologists are important. So going forward, I think that as a geologist, you need enough understanding of how AI and machine learning works to be able to communicate with the data scientist. You will definitely not have to write code, but you need to have a common language. And this is something where we're learning at the moment as well. There's been quite a few funny misunderstandings between us and the data scientists. But that is something, you know, go a little bit deeper into understanding what happens in AI and machine learning can help you with the communication. And I think that's important. The most important point here is that solid understanding, and I mean solid understanding of geology, geochemistry, structural geology, geophysics, all the things I mentioned before, and hands-on experience from the field. All of these are key to be able to be this person that can help the data scientist to create the algorithms and that we are going to use in the future. And you're needed to create the training data for these tools. And also when it spits something out in the end, who's going to tell when there's a flaw? Well, we need to really understand geology. So old school geology is not dead. I think there is a real risk that the expert geological knowledge is lost when we're starting to trust computers too much. And this might, or actually it will inevitably lead to shit in, shit out. You've heard that before about things. So solid understanding of geology and geological processes, it's still needed. And the other thing is, I've already touched on this several times, but no one knows it all. So the key in the future is to build teams with strong competence in both data science and the geosciences. And these teams needs to work well together and understand each other. So for this reason, I think teamwork skills. And now, when I'm saying teamwork skills, now I don't just mean that at the university you get some assignments together in a group and you try to solve this. I think a good thing to do is to think about yourself. You will never be able to change anyone else, but you can change how you function in different ways. That's the only thing you actually can influence. So think about, how do I function in a team? And get to know yourself. What roles do you normally take? How does that affect the group? How well do I communicate with people and listen? This is always two ways. And how can I improve? And by doing so, contribute to a positive atmosphere and in a team, and bringing that efficiency that a really good team can give. These are things that I don't know how much you get of this at university. I certainly didn't get much when I was doing my studies, but I think these soft skills are going to be very important. So it's also something that you can look into on your own. There's a lot written about these things, and just reflecting as well, and thinking about this in different situations where you find yourself in teamwork. So those are really the takeaways I want to give you from me. And then I'm going to end with, I have a thanks for listening slide here at the end, but I think I end on this one so it can stay up for a little bit. But I just wanted to show you that in Boliden we do have the possibilities for internships. We don't do that very often, and it's very ad hoc, so you have to be lucky. But don't hesitate to send me an email if you're interested in stuff like that and you have ideas. Master's projects, we do around 4 to 5 of those every year. It's a bit the same there. You have to be a bit lucky, because we need to have a good project here in Boliden to do it, and we need internal supervisors and time as well. So you need a bit of luck, but please send a CV and personal letter to me if you're interested, and do it well in time, because the more time you have, the easier it is to get lucky with the timing, I suppose. And then I want to just flag that we also do summer geologists, which is the paid job during the summer, helping with mapping and sampling and other exploration related work. And this is always advertised on the Boliden career site. And normally it comes up in February. It might already be up there, so I haven't looked recently. But if you go into boliden.com and career, you can see if there are any advertised summer jobs there. This is, of course, also where you look for normal job applications. So keep an eye on that site for the future. That's all from me. So thank you.